Okay, so we are going to go over a different method of factoring that is quite simple, and while we can do factoring by grouping, this way also works and it's a little bit faster. So we always want to add to this middle number, but in order to actually find the number that's going to multiply, we have to take into account this 4 and this -5. So we're going to multiply 4 times -5 to get -20. And we want two numbers that add to -19. So that would be -20 plus 1. That adds to -19. So in the past, we would split this and we would factor by grouping. But we're going to do something slightly different. Okay, so this is x squared, so we're going to say that x times x is x squared, just like we did in the past. And then we're going to take those two numbers, -20 and 1, -20 and +1, and we're going to put them there. But because we had to multiply 4 times 5, we're going to take this 4, and we're going to divide both of these numbers by 4. Now, some of it will simplify, but not all of them will. So this one simplifies to be x minus 5. The second one does not. So we're going to take this 4, and we're going to move it to right in front of here. And this is not necessarily for any other reason other than someone noticed a shortcut that this works. So we've got the 4 in front of the x, and then +1. Now, we can double check that this works by distributing back out. So x times 4x is 4x squared. X times 1 is +x. Distributing the 5, we go -5 times 4x is -20x. And 5 times 1 is -5. Sorry, -5 times 1 is -5. This becomes 4x squared minus 19x minus 5. And that's what we started out with. Okay, so let's try a different one over here. So we have 6x squared plus x minus 12. So we need to multiply 6 times -12 to get -72. And we're going to try to think of numbers that would add to +1. Okay, now 72 has a lot of factors, so sometimes I find it more helpful to make a table of values and say, well, I know they need to add to a positive, so I'm going to make the bigger number positive and the smaller number negative. So 72 times -1, that doesn't add to +1, but I'm just going to keep going. And actually, normally we'll go -1 and 72. Now, this can divide by 2, and we'll make it negative, and that would divide by 2 to give us 36. Those don't add. -3. 3 goes into 7 twice with the remainder of 1. 3 goes into 12 4 times. Okay, that doesn't work. -4. That goes into 7 once with the remainder of 3, and that goes in 8 times. That doesn't work. 5 doesn't go. 6 works, and that's 12, we know. That adds to +6, which doesn't help us. 7 doesn't work. 8 could work, so 8 times 9, so -8 times 9 is 72. Well, those add to 1, so those are going to be my 2. Okay, so again, we start off with x times x is x squared. Put the -8 and the +9 wherever you'd like, put one of them in each side. And then we're going to take that 6, and we're going to divide both of them by 6. Okay? Now, these can each simplify to give us x minus 4/3 and x plus 3/2. But since we have fractions still, we're going to take those denominators, and we're going to move them out front. And this time we have to move it twice. So this one's going to be a 3x and -4. And then this one's going to be a 2x plus 3. And again, I could check and see. That gives me 6x squared. That gives me 9x. This gives me -8x, and this gives me -12. And that combines back to this one. Okay, so let's try that again over here. Now, this problem is actually different because I have a GCF. So I can factor out an 8 from all of these. So this would be 8 times x squared minus 7x plus 6. And so now I'm going to just factor this trinomial right here. Okay. Now this time I have a leading coefficient that we don't necessarily see, but there's a 1 here. And I'm still going to multiply 1 times 6 to get 6. Two numbers that multiply to positive 6 but add to negative 7 are negative 1 and negative 6. So we have x times x is x squared, negative 1, negative 6. Now, just like we did in the last several ones, we could still divide by that leading coefficient. Divide by that 1 right there. But when I divide by 1, it doesn't change my value. So I have 8 and then x minus 1 and x minus 6. So that would be my factored form. Okay, and up here, our factored form was this. And over here, our factored form was this. So let's try it one more time. So first, we're going to multiply 3 times 8 to get 24. Two numbers that multiply to 24 and add to negative 14. Again, we can make our table of values. So they're both going to be negative. So negative 1, negative 24 doesn't work. Negative 2, negative 12. Hey, that works. So we have x minus 2 and x minus 12. But we have to take into account that leading coefficient of 3. Okay. This second one simplifies to be x minus 4 because 12 divided by 3 is 4. This other one is in its simplest form, so I can go ahead and move it. So we have 3x minus 2. So this is going to be our factored form. So when you're doing this, you need to always remember to divide by that leading coefficient and simplify any fractions that can simplify. In this example, we had to simplify here and here and before we moved. But this is one way that works every time when you're factoring and if it factors. If it doesn't factor, then unfortunately we cannot do this method. But you could do completing the square or the quadratic formula and you'll end up with an answer that has a square root in it if there are no if it doesn't factor nicely. Okay, let me know if you have any questions about factoring when you get to school on Monday.